This is a quick video to show you how I created this cool tractor beam effect using geometry nodes. So let's get into it. I've set up a test file to make it easier to see and to save some time. So the kind of idea is a rock going towards a gold ship, and we want it to deflect away to the left as I'm looking at it there. That's kind of the idea behind it. So let's have a look. You can see that you've got a target object, which is the rock, and you've got a ship. So we're going to create a brand new collection, and we're going to call it Tractor Beam. And then we're going to add two empties, which are going to be used to give us the start point and the end point of the tractor beam. And as I go through this, I'm going to name the things, hopefully quite legibly, because otherwise I tend to forget what they're for as well. So the first one I'm going to name Tractor Emitter, i.e. where the tractor beam comes from. And the second one I'm going to name Tractor Impactor, i.e. where the tractor beam hits, which is kind of fairly straightforward. Right, so now we've created them, we're going to parent them to the rock and the ship, so that the emitter always comes from the ship and the impactor is always attached to the rock. So when I'm going through here, I'm just doing the standard parenting, which is where you select an object, control click to set the parent for it, and then control P to parent it, and similarly for the others object, and you can see them there, they've been attached appropriately. They're in the wrong location, so I'm just going to quickly move them to the right place. So use Shift S to move the cursor around, and then use Shift S again to move the selection to the cursor. That's just to put them in the right place. Sorry, I should have done that first, but never mind. Okay, so now that they're paired up, and you can just see the empty there moving appropriately, we're going to now set up the Geo Node. So let's go back to our collection and actually put the name in properly. I can spell, I promise. And we're going to create a new object, which is going to be basically what we're going to attach the geometry node to. So we create a plane, and let's zoom in and see that. I'm just going to isolate it on the display to make it a little easier for us to work with. Using the backslash. Go into edit mode, and I'm going to delete all but one vertices. All but one vertex? All but one vertex. So delete all the vertices and leave the rest there. It's quite important to get the origin set back to the one vertex you've got. So come out of edit mode and then do object, set origin to geometry. And the origin point moves to this where the dot is. So we're just going to get the Geo Node moved back to where we want it to be and then rename. So just use the usual, move the 3D cursor around and then select it. And then we're going to rename it as well, so that it actually makes some more sense. Next, we're going to add two constraints to the Geo Node. One, so that it's actually always attached to the tractor emitter. And then another one, so it's pointing at the tractor impact point. And that means it's always going to be oriented correctly. Right, so we're going to just add a material to the tractor, a very simple material. You guys can go off and do shading with, lots of the experts. So we're literally going to add just a very simple blue emission color. So now finally, we can start building our Geo Node. So let's switch over to the Geo Node editor. And this is the default view that you get when the Geo Node first appears. We can delete the group input because we don't actually need that for this particular geographical node. I'm not 100% sure when you do need them, but I'm sure there's a good reason. All right, so let's add our first thing, which is our mesh primitive, so that we can actually create a cone. So we're going to go over to the add menu and add mesh primitive, and we're going to add a cone. We're going to use that because it's just easier to actually manage with. At the top there, good, okay. There we go. Right, when we create the cone, we actually need to flip it on its head so that the narrow point is actually at the emitter and the wide point is going to hit the object. So that's why we flip around the radius and top measurements. And you'll see there that the cone is now pointing with the narrow bit inside the emission, and the wide bit is going to be heading towards the impactor at some point. You can actually create as many vertices and segments as you want. I'm not convinced it makes that much difference for this particular example. It's up to you. Next, we're going to add a transform node, and this will allow us to change the shape of the cone using the normal transform vectors for location, rotation, and scale. We're only going to use the scale one, and I actually like to feed the information into the scale via a combined XYZ node. It just means I can then, if necessary, have different values being pumped in there. It's easier to manage than having it in one place. And in this case, I happen to know that I want this particular scale to narrow the end. And we should see when we connect it, the end of the cone. There we go. So that to me is more of a tractor beam kind of profile. It wouldn't be a full circle. I guess it could be, it's up to you. But that feels kind of more logical for me. It's just the way my mind works. All right. Next thing to do here is to then somehow we have to work out how long this beam is going to be, i.e. how far is it from the emitter to the actual point where the beam is impacting. To do that, we're going to add in two object information nodes, and they will give us the location of the emitter and the impact point. Object info, duplicate it with a Shift D, label the first one, the tractor impactor, and the second one, the tractor emitter, just so we know which one is which, and obviously assign them appropriately. Now we're going to take these and we're going to use some vector math to actually calculate the distance between them. Fortunately, there's actually a function within the vector math node which makes it really simple, i.e. just choose distance and then attach the two locations. Much easier than trying to work this stuff out using trigonometry, trust me. Alright, so we now have the distance between the two as a value that we can then do some stuff with. So we're going to create a few more nodes here. We're going to put a value node in, and this actually is essentially a switch which allows us to determine how far the beam has propagated. So I've called it the propagation factor. So when this switch works, 1 will be the beam is at full length, and when it's 0, the beam won't be displaying at all. And this allows us to actually gradually have the beam propagate later on. You'll see how it works in a second. Then we add in a math node, which basically multiplies this factor by the distance. So when the factor is 1, we get all of the distance, and when the factor is less than 1, we get whatever particular fraction applies. Again, pretty straightforward, so I don't think I need to explain that much more. Let's make some room. We're going to attach the output of this into the depth socket of the cone, which governs its length, and we should see the cone now change in size. Oh, actually, you can't see it very well in this. Let me just change the orientation. I forgot to say that when we do the constraint, what we should have done is actually at that point worked out what the orientation it should be. So let's just quickly change that now. I think it's Z. Right, okay. So now you can see, there we go, that's better. Right, now you can see how the cone changes in length according to how far it is from the emitter, from the impactor, sorry. Right, next thing we're going to do is add in some other attributes that allow us to work out how wide the ends of the beam should be. By that I mean, when the beam hits an object, you don't want it lapping around the sides. You want it to be the same size as the object. So you want the ability to have the beam change its width according to how big the object is at any point in time. We're going to grab it from the object info node, label it accordingly, and we're going to use the bounding box node, which gives us the properties of the bounding box around the object. And I'll just show you that, just in case you haven't used that before. So if I go to the object and I change the display to boundary, this is what is called the bounding box, and it's the area and space that the object occupies, which isn't always what you see on the screen. Right, so now we have the bounding box, and we can use the vector maths again to actually take the minimum position of the bounding box away from the maximum position of the bounding box, and that gives us basically how wide the bounding box is. We'll use a math node to reduce it to just under half to give us the required radius for the cone, and then we'll apply the propagation factor as we did earlier. This will ensure that when it has a 0 length, it has a 0 width, and vice versa. I'll just show you how this works. We're going to increase the radius so it's ridiculously big, and then we're going to attach this factor, this calculation rather, to the radius top, and bam, there you go. If the target object is asymmetric, then the cone width will vary according to the orientation that faces the emitter. Okay, now our beam is oriented properly, it's sized properly, and it moves with respect to the two empties that we use to control it. So we've pretty much got the whole beam put together. All we need to do now is to actually animate that propagation. So we move the timeline to the middle of our 100 frame action, and what we're going to do is go to that propagation factor, which you remember was all the way down here, and we're going to set a keyframe using I. So 1, that means you display it at its maximum length. Then we're going to go to the beginning and change that to 0 and set a keyframe like this, and then go to the far end and change that to 0 and set a keyframe there as well. Again, use I. You can also right click to set or replace keyframes, as long as the cursor's on the actual field. So what you see now is that the beam, there we go, actually changes length according to the keyframes. What we need to do now is have the beam constant for a while rather than immediately moving back to the emitter. So we're going to copy the high point and just extend how long it stays fully extended for. That's still a bit too short, so let's grab it and drag it all the way out. I guess you expect the beam to stay in contact with the asteroid for quite a long time. Right, let's try that now. That looks a little better. Still probably a little more aggressive on the fall off. So let's drag this back towards the beginning some more. There we go. And we're going to drag the other point all the way in, I think. Yeah, I think we need that to come all the way up. Yeah, it's better. Okay. Right. There we go. Nice and fast to hit the object and nice and fast to release. Yeah, much better. Okay, good. The only thing left now is to actually give the beam a color, because at the moment it's still just kind of basic gray. So we're going to attach a shader to it. To do this, we'll add a set material node just after the transform node. And now, when we scrub it, you have a blue beam. Yay! Now, grab yourself a decent material. I use one from Curtis Holt. And if you do that, you should be able to get this sort of cool effect. That's it for my first ever Blender YouTube tutorial. I hope it was useful. If so, add some likes and let me know what you think. Have a good day, guys.